Right, so this is going to be Chemistry 106, I believe. Yeah, no, 105, sorry. Um, so, actually, I think it's 106. I'll double check. Anyway, here are the notes. So, water vapor and liquid water, if you have them together, they can be at equilibrium. And all that means is that the water vapor is turning into liquid water at the same rate that the liquid water is turning into water vapor. That's what it means. Um, if you are given the number of moles, and you are asked to find the number of particles, all you need to do is multiply by Avogadro's number. If you're given the number of particles, you divide by Avogadro's number to get the moles. Okay? That's all there is to it. Remember, the Avogadro's number is 6.02 times 10 to the 23rd particles per mole. Now, in this particular question, they asked us how many particles of O2. So all we have to do is multiply 14 by 6.02. If they had said how many atoms of oxygen, because this is O2, we would have to double our answer. Okay? But the question on the exit ticket says particles of O2. So you would just multiply by 6.02 times 10 to the 23rd and get your answer. This is not the answer because there's a different starting number on the exit ticket, but that is how you do it. Again, equilibrium just means that the forward reaction happens at the same rate as the reverse reaction. All right, so here we have 4 solutions. We have one that's blue-green, we have a clear one with crystals, a clear one with some dissolved stuff in it. They all have dissolved stuff. And then we have a yellow one with crystals. A, B, and C conduct electricity. These are supposed to be lightning bolts. So they are electrolytes. And they all are exothermic, which means they are giving off heat. Okay. Now, we can tell from this data that B and D are saturated. We know they're saturated because there's crystals in them. So that means they were super saturated. And then as they cooled, the crystals crystallized. And once the crystals crystallize, then you have an equilibrium of sorts between crystal growth and dissolving of the crystals. And at that point, you have a saturated solution. So the A and C could be saturated, but they could also be unsaturated. Okay? But B and D we know are saturated, or they're the most likely to be saturated because they have crystals. This one with my red dot and this one, the electron is absorbing energy and moving to a higher energy state. Okay, so they're excited. In A and B here, the electrons are falling down, so that means they're giving off energy, they're losing it. And A is only falling from one energy level to the next, right? And B is falling 2 energy levels. So we know that B is going to give off a higher energy photon because it must have absorbed more energy to move up 2 energy levels. And so then when it falls back down 2 energy levels, it's going to give off that same amount of energy. All right, so that's it for this chemistry review. Have a good day, and I'll see you in class.